Our home star, the Sunday. It is a word so deeply woven into the fabric of our existence that to speak it is to invoke the very concept of life itself. It is the first artist, painting the dawn across the canvas of the sky each morning with strokes of gold and crimson. It is the silent partner in the grand conspiracy of life, the catalyst for that miraculous alchemy we call photosynthesis, turning light into leaf, into breath, into being. We feel it on our skin as a gentle warmth, a benevolent caress that reassures us of our place in the cosmos, a reminder that even across an expanse of 93 million miles, we are tethered to a source of unwavering power and constancy. It is the metronome of our days, the anchor of our seasons, the protagonist in our most ancient myths. Cultures across millennia have worshipped it as a deity, seeing in its daily journey from darkness to light and back to darkness, a metaphor for their own ephemeral existence, a promise of renewal, a symbol of enlightenment, a force against the shadows of the unknown. We have built monuments to align with its solstices, written poetry to capture the fleeting beauty of its setting rays, and composed symphonies that echo the grandeur of its rising. In our collective human consciousness, the sun is a known quantity. It is the giver, the nurturer, the steadfast guardian of our small blue world. It is a predictable and comforting fire in the hearth of our solar system, a presence so fundamental that we often take its gentle gifts for granted. This perception, this intimate and personal relationship with a star, is perhaps the most profound and comforting illusion humanity has ever collectively embraced, because the truth of our sun, the reality that lies beyond the soft filter of our atmosphere and the vast insulating vacuum of space, is a truth of unimaginable violence. The gentle warmth we feel is but the faintest echo of a furnace so ferocious it defies earthly comparison. The soft light that nourishes our world is the diluted remnant of a continuous nuclear detonation that has raged for 4.5 billion years. Our sun is not a gentle lamp. It is a cauldron of plasma, churning at temperatures of millions of degrees, a seething, chaotic sphere where gravitational forces so immense are constantly at war with the explosive power of nuclear fusion. It is a place where magnetic field lines, thousands of times stronger than Earth's, twist and snap like colossal cosmic whips, unleashing solar flares, tongues of fire the size of entire planets that erupt into space with the energy of billions of atomic bombs, great clouds of charged particles, coronal mass ejections weighing more than mountains, are periodically hurled from its surface at speeds of millions of miles per hour, generating a perpetual storm we call the solar wind, a tempest that rages across the entire solar system. The sun we see, the placid yellow orb, is a carefully curated masterpiece of distance and atmospheric shielding. We are living in the quiet, distant countryside, feeling the gentle breeze, while utterly oblivious to the fact that just over the horizon lies a hurricane of incomprehensible scale and fury. We are admiring a magnificent lion through a pane of impossibly thick protective glass, marveling at its golden mane, while remaining safely ignorant of the raw, untamable power contained within. And now, into the heart of this storm, into the very throne room of this violent king, a stranger is about to walk. From the great, silent darkness between the stars, a wanderer has arrived. It is an object born not of our sun's fire, but of the cold, primordial dust of a different, unknown stellar neighborhood. A traveler named 3I Atlas is on an irrevocable trajectory, a path that will carry it directly into the crucible of our solar system. For a few fleeting days, this ancient relic from an alien star system will face the full, unshielded, and terrifying power of our Sunday. This is not merely a celestial event, it is a confrontation, a meeting of two entirely different cosmic realities. It is a trial by fire for an object that has known only the freezing void for millions, perhaps billions, of years. What happens when a secret, held for eons in the frozen heart of an interstellar traveler, is brought into the light of a star? What truths are revealed when an artifact from the deep dark is subjected to the unmaking fire of a nuclear furnace? What happens then when an object destined for a singular, fleeting passage through our domain of light and warmth faces the ultimate arbiter of existence in this system? What becomes of a story when its protagonist must fly through the very heart of the fire? This is the fundamental question that elevates the arrival of 3I, Atlas, from a mere astronomical curiosity into a moment of profound, unrepeatable significance. To grasp the weight of this encounter, we must first unlearn one of our most ingrained celestial intuitions, the idea of return. We are creatures of cycles. We live by the rhythm of the rising and setting sun, the waxing and waning moon, the comforting return of the seasons. Our cosmic understanding is built upon this foundation of repetition. We know that Halley's Comet, that famous celestial pilgrim, will grace our skies again in the year 2061, just as it did for our grandparents and their grandparents before them. Its path is an ellipse, a closed loop, a promise of return written in the language of gravity. Its journey is a waltz, a predictable orbit where celestial partners circle and return for another term. The journey of 3I, Atlas, is nothing of the sort. This is not a waltz. It is a cosmic javelin throw. Its trajectory is a hyperbola, a mathematical term that, in the poetic language of the cosmos, simply means goodbye. A hyperbolic path is an open-ended journey. It is a line that enters from infinity and exits to infinity, bent only once by the gravitational heart of our system, before being cast out again, forever. This object is not a member of our solar family on a long trip away from home. It is a true foreigner, a stranger passing through on a grand tour of the galaxy, and our solar system is but one stop on an itinerary of unimaginable length. It is a message in a bottle thrown from an unknown shore, which will drift past our island for a few precious moments before the currents of space-time carry it away into the mists once more, never to be seen again by any human eye. This is the source of the urgency, the quiet, intense pressure that now rests upon the shoulders of the entire astronomical community. Every photon of light captured from this object, every scrap of data gleaned from its spectral signature, is a page from a book that will never be opened again. The window of opportunity is not just small, it is absolute. What we learn in these coming weeks is all that humanity will ever know of 3I, Atlas. We are, in a very real sense, the sole custodians of its memory for our species. This singular opportunity transforms the act of observation into something far more profound. It becomes a form of bearing witness. And what we are about to witness is not a passive flyby. It is a dynamic, transformative event. It is a trial. The sun will not simply illuminate 3I, Atlas, for our telescopes. It will interrogate it. It will subject this ancient traveler to a series of tests so extreme that they will force it to reveal its most fundamental secrets. The object will be heated, stressed, stretched, and bombarded. Its outermost layers, which have served as a protective mantle against the cold vacuum for eons, will be violently stripped away. The encounter is a form of cosmic archaeology, but instead of using delicate brushes to dust away the sands of time, the universe is using the blunt force of a star to blast away the layers of cosmic history. This is the central drama of the encounter, a direct confrontation between the raw, chaotic power of a star and the preserved, frozen history of an interstellar relic. It is a moment of revelation, born from the threat of annihilation. So, as this visitor from the great void makes its final approach, as it prepares to endure the fiery breath of our star, humanity stands at a unique crossroads. We are spectators to an event that is, by its very nature, a singular occurrence in the entire timeline of our civilization. We are presented with a question, delivered from the depths of interstellar space, that we have only one chance to answer. This is not just another dot of light in the sky. This is a moment of cosmic reckoning, a fleeting intersection of paths that will never cross again. And the story of what happens next, the tale of this trial by fire, will be written in the light that reaches our telescopes in these precious, unrepeatable days. To comprehend the profound drama of this impending encounter, we must first properly introduce the two combatants, the two titanic forces set to collide. For this is not merely a rock passing by a star. It is a dialogue between two entirely different epochs of cosmic history, spoken in the universal language of physics. In one corner, we have the protagonist of our own existence, the very heart of our system, the Sunday. And to truly understand it is to understand the nature of power. Imagine, if you will, an emperor, a sovereign of such absolute authority that its dominion is not defined by borders on a map, but by the very curvature of space-time itself. The sun's mass, which accounts for over 99.8% of all matter in our solar system, is not just a static fact. It is an active, unceasing declaration of its reign. Gravity is its edict. It is a silent, invisible force that reaches out across billions of miles, holding planets in their loyal orbits, shepherding asteroid belts, and dictating the final destiny of every comet that dares to venture near. It is this gravitational authority that has ensnared 3I, Atlas, pulling it from its straight, interstellar path and bending its journey into a curve of temporary submission. The sun is not a solid body, not a world of rock and soil upon which one could stand. It is a star, a seething globe of plasma, that fourth state of matter where atoms are torn apart into a chaotic soup of charged electrons and nuclei. It is less an object and more a sustained event, a controlled explosion of unimaginable scale. At its core, the pressure is so immense, the temperature so searingly high, a staggering 15 million degrees Celsius, that the fundamental building blocks of reality are forged and reforged. Here, in this cosmic crucible, hydrogen atoms, the most basic element in the universe, are crushed together with such violence that they fuse to become helium. This act of fusion is not a quiet process. It is a conversion of matter into pure energy, as described by that most famous of equations, E equals mc squared. Every second, our sun converts about 4 million tons of its own mass into a blinding torrent of light and heat. This is the source of its power, the roaring engine at its heart, a furnace that has burned without faltering for billions of years and will continue to do so for billions more. This energy, born in the core, takes hundreds of thousands of years to fight its way to the surface, passed from atom to atom through a dense, turbulent interior. When it finally breaks free, it does so in a spectacle of controlled chaos. The sun's surface is a roiling, convective sea of fire, a tapestry of bright granules the size of continents that live and die in a matter of minutes. Great arcs of plasma, called solar prominences, are held aloft by magnetic fields, forming ethereal bridges of fire that could swallow the Earth whole. This magnetic field is the sun's other weapon. It is a fantastically complex and dynamic system, a web of invisible forces that writhes and twists, storing and suddenly releasing catastrophic amounts of energy. Our star, then, is not a passive source of light. It is an active, violent, and complex entity. It is the interrogator in this story, and its tools of inquiry are fire and force. And now, approaching this sovereign of fire, is the other combatant, the wanderer, 3I, Atlas. If the sun is a roaring, open book of power and energy, 3I, Atlas, is a sealed letter, written in an unknown language, delivered from the depths of the void. Its very existence is an act of preservation against the entropy of the universe. Where the sun is a symphony of violent creation, 3I, Atlas, is a monument to silence and endurance. It is an object born in the cold cradle of a molecular cloud surrounding a different star, a different sun, in a different epoch of the galaxy's history. It is a chemical fossil, While our planets were formed from the specific protoplanetary disk that once surrounded our young sun, 3I, Atlas, was formed from a completely different recipe of elements and isotopes. The precise ratio of heavy metals, the specific crystalline structure of its water ice, the kinds of complex organic molecules trapped within its frozen heart, all of these are a direct fingerprint of its alien birthplace. It is a pristine, uncontaminated sample of another solar system, delivered to our doorstep. For countless millennia, it has journeyed through the interstellar medium, that near-perfect vacuum between the stars. In this realm, the temperature hovers just a few degrees above absolute zero. Its trial, until now, has not been one of fire, but of an almost eternal cold. It has been bombarded not by intense radiation, but by the occasional, lonely, cosmic ray. Its surface has been a testament to stasis, a library where the pages have been frozen shut for eons. It is a hermit, a cosmic ascetic, that has spent its entire life in silent, cold meditation. We call it a comet, but that is merely a label of convenience based on its current behavior of releasing gas and dust. It is a word from our own limited vocabulary, and it may not do justice to the true nature of this object. Is it a loosely bound conglomerate of ice and dust, a fragile, dirty snowball as our own comets are often described? Or is it something more dense, more resilient, a fragment of a larger, more complex body that was ejected from its home system in some long-forgotten cataclysm? We do not know. Its silence is its greatest mystery. It carries no light of its own, only reflecting the dim starlight of the galaxy. It broadcasts no signals. It simply moves, a vessel of secrets, on a predetermined path, so the stage is set. On one side, we have the sun, an entity of overwhelming power, chaos, and heat, the ultimate agent of transformation and destruction in this system. On the other, 3I, Atlas, an entity of silence, preservation, and cold, a vessel carrying the unaltered memory of a world we will never see. The encounter is therefore a clash of fundamental opposites. It is a meeting between a roaring furnace and a frozen archive. The irresistible force of the star will now be applied to this enigmatic object, and the profound question is, will the archive simply be burned, its pages turned to ash and scattered to the solar winds? Or will the heat, in its violent attempt to destroy, instead unseal the book and force it to reveal its ancient story for us to read? To say that 3I, Atlas, is on a collision course with the sun is a dramatic overstatement in terms of physical impact, yet it is a profound understatement in terms of physical influence. The encounter is not a brute force impact, but a far more subtle and pervasive trial by ordeal. It is a process of systematic deconstruction, an interrogation conducted not with questions, but with the fundamental forces of nature. Let us imagine 3I, Atlas, as an ancient, sealed manuscript that has traveled for millennia through a silent, cold, and dark archive. Now, it is being moved from that archive into a blast furnace. The ordeal begins not with touch, but with light. As the manuscript gets closer to the furnace door, the first thing it feels is the radiant heat. For 3I, Atlas, this is the most dramatic environmental shift imaginable. After an existence defined by near absolute zero, it is now being subjected to a relentless torrent of electromagnetic radiation. The sunlight it now feels is not the gentle, life-giving warmth we experience on Earth. It is a concentrated, unfiltered blast of energy. This energy doesn't just illuminate the object. It deposits itself directly onto its surface, causing the very atoms and molecules to vibrate with increasing violence. The most volatile materials, the frosts that have been stable for eons in the deep cold, are the first to succumb. Ices of nitrogen, methane, and carbon monoxide, which can remain solid at incredibly low temperatures, now find themselves in an environment where their solid state is no longer tenable. They begin to sublimate, transitioning directly from a solid to a gas, bypassing the liquid phase entirely. This is the first act of the sun's interrogation. It is boiling away the most delicate, outermost layers of the object's history, creating the initial wisps of the coma, the gaseous atmosphere that begins to shroud the nucleus. This is the process of outgassing, and it is the source of the object's newfound activity, the very reason it was discovered. But this is just the prelude. The second tool of the sun's interrogation is far more invasive: the solar wind. This is not a wind in the earthly sense, not a movement of air, but a constant supersonic stream of charged particles, mostly protons and electrons ejected from the sun's corona. It is a plasma storm that blows perpetually outward, carrying with it the sun's own magnetic field. As this storm washes over 3I, Atlas, it interacts violently with the newly formed gaseous coma. The high-energy particles of the solar wind act like a sandblaster, physically stripping away molecules from the coma and pushing them away from the sun, forming the iconic ion tail of a comet. This tail, often glowing with a faint blue light, becomes a cosmic windsock, pointing directly away from the sun, a visible testament to the invisible storm that rages throughout the system. At the same time, the less energetic but more massive photons of sunlight exert a gentle but persistent pressure on the larger dust particles that have been liberated from the ice. This radiation pressure pushes the dust into a separate, often curved, and more diffuse tail. The sun, then, is not just heating the object, it is actively disassembling it, sorting its constituent parts gas from dust, and casting them across the sky for our telescopes to analyze. But the final, and perhaps most profound, test is a force both invisible and inescapable: gravity. As 3I, Atlas plunges closer to the sun, the gravitational pull becomes exponentially stronger. This force does not pull on the object uniformly. The side of 3I, Atlas facing the sun, is pulled more strongly than the side facing away. This differential is known as a tidal force. It is the same force that causes the tides in Earth's oceans, the moon pulling more strongly on the water on the near side of the Earth than on the far side. For a small, solid planet like Earth, this stretching is manageable. But for a potentially fragile object like a comet, which may be more of a loosely packed rubble pile than a solid rock, these tidal forces can be catastrophic. Imagine a colossal, invisible hand grabbing the object and trying to pull it apart. The tidal forces create immense internal stresses, seeking out every fracture, every weak point in the object's structure. It is a test of its very integrity, a question posed by gravity itself. Are you one solid object, or are you many smaller objects flying in formation? This threefold trial by heat, by charged particles, and by gravitational stress is the essence of the encounter. It is a systematic process of deconstruction that forces the object to reveal its nature. The heat reveals its most volatile chemical components. The solar wind reveals how its atmosphere interacts with a plasma environment, and the tidal forces reveal its internal strength and structure. The manuscript is not just being held near the furnace, it is being baked, sandblasted, and stretched on a rack, all at the same time. And every crack that appears, every wisp of smoke that rises, every page that is torn loose, provides a clue to the ancient story written within. This ordeal, this trial by the sun, is a process we have witnessed before. Humanity, in its short but relentlessly curious history of sky gazing, has become familiar with this particular form of celestial drama. The arrival of a great comet in our inner solar system is a recurring motif in our story, a celestial event that punctuates the quiet continuity of the night sky with a transient, breathtaking spectacle. These visitors, our native comets, have served as our primary tutors, teaching us what to expect when ice and dust meet fire. They have provided us with a baseline, a set of established rules, a script for this cosmic play. To truly appreciate the profound anomaly that 3I, Atlas, represents, we must first immerse ourselves in this script. To understand what science considers the normal state for these celestial performers. Our comets, the ones that belong to this system, are born in the cold and the dark. They are the inhabitants of the vast frozen hinterlands of our solar system, realms so distant from the sun that its light is but a particularly bright star. The first of these realms is the Kuiper Belt, a scattered donut-shaped disk of icy bodies that begins beyond the orbit of Neptune. This is the home of the short-period comets, those that return on timescales we can comprehend decades or centuries. Think of the Kuiper Belt as the twilight suburbs of our solar city, a place of frozen worlds and primordial debris that never quite coalesced into a full-sized planet. But to find the true genesis of the great comets, the ones that appear seemingly from nowhere and dazzle us for months, we must travel much further out. We must journey to the Oort cloud. The Oort cloud is not a belt. It is a theory, a ghost, a necessary inference to explain the majestic, long-period comets that grace our skies. It is imagined as a vast, spherical shell of trillions of icy bodies, surrounding our solar system at a distance so immense it is almost impossible to picture. It is a cosmic sphere whose edge may lie a quarter of the way to the next nearest star. This is the deep, cold storage of our solar system, the great, dark attic, where the leftover building materials from the formation of the planets were flung 4.5 billion years ago and have remained in a state of suspended animation ever since. The objects in the Oort cloud are the most pristine relics we know. They are time capsules, each one a frozen, unaltered sample of the primordial nebula from which our Sun, our Earth, and we ourselves were born. They drift in a near-perfect stillness, in orbits so vast and slow that a single journey around the Sun can take millions of years. For the most part, they remain there, in silent slumber, but occasionally the delicate gravitational balance is disturbed. Perhaps the gentle tidal force of the Milky Way galaxy itself, or the passing of a nearby star, gives one of these sleeping relics a tiny gravitational nudge. That nudge is all it takes. Over thousands of years, the object begins a slow, inexorable fall inward, a journey from the absolute darkness of interstellar space toward the heart of the kingdom of light. This is the normal origin story, and as this native comet makes its multi-million-year journey, its performance upon reaching the inner solar system follows a predictable, albeit beautiful, pattern. As it crosses the orbit of Jupiter, it begins to awaken. The sun's heat starts to sublimate its ices, and the object that was once a simple, inert nucleus of ice and rock begins to grow a vast, glowing atmosphere, the coma. This is the moment of its transformation, from a mere asteroid-like body into a true comet. As it gets closer, the pressure of the solar wind and sunlight begins to sweep the material of the coma away, giving birth to its magnificent tails. We see the bright bluish ion tail, composed of gases, always pointing directly away from the sun, a slave to the magnetic field of the solar wind. And we see the broader, more diffuse, and often gently curved dust tail, which follows a path dictated by the comet's own orbital momentum and the gentle pressure of sunlight. We have seen this performance time and again. We saw it with Comet Hale-Bopp in 1997, a majestic visitor that remained visible to the naked eye for a record 18 months, its twin tails stretching across our northern sky. We saw it again with Comet Neowise in 2020, a sudden, beautiful apparition that offered a moment of collective wonder to a world in the grip of uncertainty. When these objects are put through their trial by fire, we have learned what to expect from their composition. Spectroscopic analysis has shown us, time and again, that they are made of familiar stuff. The dominant ice is water, H2O, the same water that fills our oceans. They contain frozen carbon dioxide and carbon monoxide, ammonia and methane. Their dust contains silicates, the same basic rocky material that makes up the Earth's crust, and complex carbon-based organic molecules, the very building blocks of life. They are, in essence, a part of us. They are distant, icy cousins, but they share our chemical DNA. They speak a language of chemistry that we can understand because it is our own. This, then, is the established normal, the state of the union for cometary science. A great comet is a relic from the Oort cloud. Composed of a familiar recipe of ices and rock, it awakens near Jupiter, grows a coma and two distinct tails, performs a spectacular show as it rounds the sun, and, if it survives the tidal forces, begins its long journey back to the cold and the dark, perhaps to return in another million years. This is the script we have come to know. This is the beautiful, predictable, and deeply familiar dance of our native comets. But 3I, Atlas, did not come from our Oort cloud. It did not come from the Kuiper belt. It arrived on a hyperbolic trajectory, a path that screams of an alien origin. It is a messenger from an entirely different Oort cloud, one that circles a different star. And so the profound question hangs in the air, a question being asked in every observatory and university across the globe. Will this visitor, born of a different nebula, composed of a different chemical recipe, and with an unknown history, follow the same script? Or, when placed upon the same stage and subjected to the same fiery interrogation by our sun, will it perform a completely different play, one whose language we do not yet understand? The baseline has been set. The normal state is understood. And against this backdrop of familiarity, the truly bizarre nature of the data beginning to stream in from 3I, Atlas, can finally be appreciated. And so, with the script of normalcy firmly established in our minds, with our understanding of our native comets as the accepted text, we turned our collective gaze toward the approaching stranger. Science, after all, is a conversation between theory and observation, a dance between what we expect to see and what the universe, in its sublime indifference to our expectations, actually reveals. And from the very first streams of data, from the initial whispers of light captured by the sentinels of glass and steel that stand guard upon our planet's highest peaks, it became devastatingly, beautifully clear that 3I, Atlas, had no intention of following our script. The story began, as it always does, with discovery, a faint smudge of light, moving with a purpose that betrayed its celestial allegiance. Initially, it was just another designation in a catalogue, another suspect in the nightly lineup of asteroids and comets. But as observatories around the world turned to confirm it, a new plot began to emerge. The calculations of its trajectory, refined with each new data point, began to converge on a single, astonishing conclusion. The eccentricity of its orbit was not just high, it was greater than 1. To an astronomer, this is not a number, it is a proclamation of otherness. It is the mathematical signature of an unbound object, a traveler merely passing through. This was not a prodigal sun returning from the cold depths of our own Oort cloud. This was an emissary from an unknown star. With this confirmation, a quiet, electric current of excitement and purpose surged through the global astronomical community. This was not just another comet. This was a second chance, a third visitor, after the fleeting mystery of Oumuamua and the more conventional 2I, Borisov. But this one was different. It was larger, brighter, and it was awakening. As it crossed the frost line, that invisible boundary in our solar system, where the sun's warmth becomes potent enough to sublimate ices, 3I, Atlas, began to perform. Its coma, the shroud of gas and dust that is the hallmark of a comet, began to blossom. But the blossoming was on a scale that was startling. It was as if we were watching a flower bloom in fast forward, its atmosphere swelling to a size that would soon rival the planet Jupiter. Yet, it was not the size of the coma that was most captivating, but its character. It was the light itself. When astronomers passed this faint, ghostly light through a spectrograph, an instrument that acts like a prism, splitting light into its constituent colors, they began to read the first lines of this object's story. The resulting spectrum is a barcode of existence, with dark and bright lines revealing the chemical elements and molecules present in the coma. And there, as expected, were the familiar signatures of cyanide, and most prominently, of diatomic carbon, or C2. This molecule, two carbon atoms bonded together, is a common component of cometary comas. When bathed in the ultraviolet radiation of the sun, its chemical bond is excited, and as it relaxes, it fluoresces, emitting light in a very specific shade of ethereal, spectral green. This is the source of the characteristic green glow seen in so many comets. On the surface, this was a comforting sign of familiarity. It was speaking a chemical dialect we could understand. But the intensity of this green light was perplexing. For an object still so far from the sun, the sheer volume of diatomic carbon required to produce such a vibrant glow was enormous, hinting at a composition unusually rich in complex carbon chain molecules. It was like recognizing a familiar melody, but hearing it played with an orchestration so powerful and strange that it became something new and unsettling. It was the first clue that the recipe used to bake this particular celestial body was fundamentally different from our own. Yet this was a subtle clue, a point of academic debate, the piece of evidence that truly fractured the conventional narrative, the observation that transformed 3I, Atlas, from a mere anomaly into a profound mystery, was hidden not in its light, but in its motion. The laws of celestial mechanics, as laid down by Kepler and Newton, are among the most precise and triumphant achievements of the human intellect. We can predict the motion of planets with the accuracy of a divine clockmaker. We can account for the gravitational pull of every major body in the system. When we plotted the path of 3I, Atlas, we did just that. We calculated the immense pull of the Sun, the gentle nudges of Jupiter and Saturn, every gravitational influence that should dictate its path. And we found that the calculations did not match the observations. 3I, Atlas, was not precisely where it was supposed to be. The deviation was minuscule, a tiny error on an astronomical scale, but it was persistent, and it was undeniable. The object was moving as if it were being pushed by a gentle, unseen force, a whisper of acceleration that had no place in Newton's pristine equations. This phenomenon itself is not new. We call it non-gravitational acceleration, and we see it in our own comets. The explanation is straightforward. As the sun heats the nucleus, jets of gas and dust erupt from its surface, acting like tiny, chaotic rocket thrusters, giving the comet a push. But the push from 3I, Atlas, did not feel like the push of a typical comet. The outgassing we could see, the amount of dust and gas being liberated, seemed insufficient to account for the magnitude of the acceleration. It was as if we were watching a grand sailing ship move across the ocean, and we could see a small, gentle breeze in its sails. But the ship was accelerating, as if being driven by a gale-force wind. Furthermore, the push from a typical comet, a tumbling, irregularly shaped body with jets firing sporadically from random active regions, is usually erratic. It causes the comet to wobble and drift unpredictably. The push on 3I, Atlas, however, was different. It was smooth. It was constant. It was a gentle, continuous pressure that seemed to guide the object along its path with an unnatural grace. It was less like the sputtering of chaotic jets and more like the thrust of a highly efficient, low-power engine. This was the ghost in the orbital mechanics. This was the data point that opened the door to radical speculation. Here was an object of alien origin, larger and more active than expected, glowing with a strangely intense chemical signature and moving as if guided by a force that we could not fully explain with our established models. The data, in its cold, impartial language, was painting a portrait of a paradox. It looked like a comet. It talked like a comet. But it was not moving like a comet. The first act of the story was complete, and it had ended not with a resolution, but with a far more elegant and profound riddle. The eyes of humanity, our network of telescopes and sensors, had delivered their initial report, and that report was a formal invitation to question everything we thought we knew. And so, the stage is set not by a playwright, but by the impartial laws of orbital mechanics. The perplexing data, the strange glow, the anomalous motion, these are not merely curious footnotes in an astronomical journal. They are the prologue to the main act. They are the riddles posed in the first chapter of a story that is hurtling toward its climax. For science, a mystery is not an endpoint. It is a catalyst. It is a source of potential energy, a coiled spring of inquiry that is released in the form of focused, pointed questions. And the approaching perihelion, the moment of closest approach to the sun, is not just a spectacle to be passively observed. It is the singular, unrepeatable experiment that promises to provide the answers. It is humanity's one chance to turn the interrogator's light back upon the object itself. In this grand experiment, our primary instrument, our most sensitive and powerful eye, is the James Webb Space Telescope. To call it a telescope is to do it a disservice. It is a time machine, a chemical laboratory, and a heat-seeking oracle, all folded into a magnificent instrument of gold-plated beryllium. Stationed 1,000,000 miles from Earth, its power lies not in the visible light our eyes can see, but in the invisible realm of the infrared. This is the light of heat, the glow that all matter emits, the ancient, stretched-out light from the dawn of the universe. And for an object like 3I, Atlas, the infrared is where its deepest secrets are written. We hope, with an intensity that borders on prayer, to use the Webb to perform a definitive act of cosmic archaeology. As the sun's fire bakes the surface of 3I, Atlas, it is not just sublimating the simple frosts, it is liberating a library of molecules that have been trapped in its icy matrix for eons. The Webb's spectrographs are designed with exquisite sensitivity to read the infrared signatures of these molecules as they spill out into the coma. We are not just looking for the simple, familiar compounds. We are hunting for bigger game. We hope to see the unambiguous spectral fingerprints of complex organic molecules. We are searching for tholins, those reddish, tar-like substances created when simple organic compounds are irradiated, which are thought to be precursors to the chemistry of life. We are searching for polycyclic aromatic hydrocarbons, or PAHs, complex rings of carbon that are scattered throughout our own galaxy and are thought to be crucial ingredients in the primordial soup. And, in the most optimistic of scenarios, we are searching for the building blocks themselves, the faint but unmistakable signatures of amino acids, the fundamental components of proteins. To find such molecules in an object from another star system would be a discovery of staggering philosophical weight. It would be the first direct evidence for the theory of panspermia, not as science fiction but as a plausible galactic process. It would suggest that the ingredients for life are not a unique local invention, but are instead common, ubiquitous cargo, shipped across the interstellar void, seeded from one star system to the next. The water ice that is almost certainly the main engine of this object's activity holds another secret we hope to unlock. Water, H2O, is not all the same. In the great cosmic ocean, there exists a heavier version of hydrogen, an isotope called deuterium, which has an extra neutron in its nucleus. Water made with this isotope is called heavy water. The ratio of normal water to heavy water, known as the D-H ratio, is a powerful tracer of an object's origin and history. In our solar system, this ratio varies. The water in Earth's oceans has a specific D-H ratio. Some comets we have measured match this ratio, leading to the elegant hypothesis that Earth's oceans were delivered by cometary impacts in its youth. Others do not match, complicating the story. By using the Webb to precisely measure the D-H ratio in the water vapor erupting from 3I, Atlas, we hope to taste the water of another world. Will its D-H ratio be similar to our own, suggesting a universal standard for water in this corner of the galaxy? Or will it be wildly different? A chemical signature that proves its alien heritage and tells us that the water from which our own life emerged is just one of many possible flavors. Finally, our hopes extend beyond chemistry to the realm of pure physics. The smooth, non-gravitational acceleration remains the most profound enigma. The perihelion passage is the ultimate test for this phenomenon. As the object is subjected to the maximum thermal and gravitational stress, we will watch its motion with unprecedented precision. If it is a natural comet, we expect its outgassing to become far more violent and chaotic. The smooth push should give way to a sputtering, unpredictable series of thrusts as new vents and fissures open up on its surface. We hope to see this chaos, as it would be a comforting confirmation of a natural process, even if an unusually efficient one. But if the acceleration remains smooth, if the object holds its course with that same unnatural grace, even under this immense duress, then the mystery deepens into something far more unsettling. We hope to see it flex, to see it crack, to see it behave like a natural body under strain. The alternative, an object that seems engineered to withstand these forces, is a possibility that science must be prepared to entertain, however reluctantly. These are the hopes that animate the long nights in observatories around the world. We are no longer just passive observers of a passing light. We are active participants in an interrogation. We have our questions prepared. We are searching for the ingredients of life, the taste of alien water, and the source of a ghostly, impossible push. The sun will force 3I, Atlas, to provide its testimony, and with instruments like the Webb, we are ready to take the deposition. The ultimate test, however, goes beyond the subtleties of chemistry and the elegance of orbital dynamics. It is a far more primal, more brutal question. A question not of composition but of constitution. It is the question that every celestial body must answer when it ventures too close to a star. What are you made of? And how well are you put together? The encounter with the sun is not just an interrogation. It is a physical examination of the most invasive kind. It is an attempt to discern the very soul of the object by subjecting its body to an almost unbearable strain. The chief instrument of this physical test is the invisible hand of gravity, expressed as a tidal force. And to truly understand this force, we must abandon the notion of gravity as a simple pull. It is a gradient, a difference. As 3I, Atlas, approaches the sun, the star's immense gravitational field does not pull on the object as a single, unified whole. It pulls more fiercely on the atoms on the near side of the object than it does on the atoms on the far side. This difference in pull, this relentless stretching across the body of the object, is the tidal force. It is a cosmic tug-of-war, with the sun pulling on the front of the object while the object's own inertia and the lesser pull on its backside try to hold it together. This is the most intimate of questions, for it probes the object's deepest history. The way it responds to this stress will reveal the story of its own formation. Was it born in a gentle accretion process? A slow, peaceful gathering of ice and dust into a loosely bound, fragile conglomerate? If so, its internal structure might be weak, like a poorly packed snowball, full of voids and fractures. In this case, the tidal forces might be its undoing. The constant stretching could exploit these internal weaknesses, causing great chasms to open on its surface. We might witness a catastrophic failure, a moment when the object can no longer withstand the strain and breaks apart into a procession of smaller fragments, a string of pearls following the original orbit. Such a disintegration would not be a scientific failure. It would be a triumph. As the great planetary scientist David Grinspoon once alluded, sometimes the best way to understand something is to see it break. The fragmentation of 3I, Atlas, would be a creative act of destruction. It would be a cosmic autopsy, laying bare the pristine, primordial material of its core for our spectrographs to analyze. Each new fragment would become a new world to study, its freshly exposed surfaces offering an unadulterated glimpse into the chemical and physical conditions of the alien protoplanetary disk, where it was born billions of years ago. Conversely, what if 3I, Atlas, is not a fragile snowball? What if it is a far more resilient object? Perhaps it is not a primary accretion body, but a fragment of a much larger parent body, a dwarf planet that was shattered in a violent collision in its home system. Such an object would have been subjected to immense pressures and temperatures in its past, forging it into a denser, more structurally sound body. It would be less like a snowball and more like a solid piece of rock, laced with ice. If this is its nature, it might withstand the tidal forces with barely a shrug. It might pass through the crucible of perihelion wounded, perhaps, its surface forever changed, but with its core integrity intact. Its survival would tell us a different story, a story of a violent and dynamic past, a tale of celestial collisions and shattered worlds in its system of origin. This, then, is the ultimate physical test. It is a simple binary question posed by the universe itself. Will it hold, or will it break? The sun, in its role as the great interrogator, will apply the pressure, and the answer provided by 3I, Atlas, will not be spoken in words, but in its very physical fate. We stand ready to witness that answer, to read the story written in the fractures of its potential demise, or in the silent strength of its survival. The moment of maximum stress is approaching, and with it, a moment of profound revelation. And so, as the moment of reckoning draws near, as this interstellar wanderer prepares for its ordeal by fire, we must begin our own journey of intellectual inquiry. In the grand courtroom of science, before we allow ourselves to be seduced by the allure of extraordinary claims, we are duty-bound to first give a full and fair hearing to the ordinary. This is the principle of Occam's razor, the elegant idea that the simplest explanation, the one that requires the fewest new assumptions, is often the correct one. And in the case of 3I, Atlas, the simplest, most rational, and most scientifically sound explanation is also, in its own right, a thing of profound beauty and wonder. This first scenario, the foundational step on our ladder of hypotheses, is that 3I, Atlas, is not a derelict starship or a harbinger of a new physics, but is, quite simply, a comet. Not just any comet, to be sure, but a magnificent specimen of its kind. A super comet, a visitor that pushes the known boundaries of what a comet can be, yet a comet nonetheless. In this scenario, we are not witnessing the arrival of something wholly alien to our understanding, but rather a rare and majestic example of a familiar phenomenon. We are like naturalists who have spent a lifetime studying the familiar birds of our local forest, and then one day, a condor, a creature of staggering size and wingspan, soars overhead. It is still a bird, it has feathers, it flies, it adheres to the known principles of biology, but its sheer scale forces us to expand our definition, to redraw the boundaries of what we thought was possible for a bird to be. 3I, Atlas, in this view is the condor of comets. Its immense size, estimated to be perhaps 20 times larger than a typical long-period comet from our own Oort cloud, is the master key that unlocks many of its other mysteries. A larger nucleus is not just quantitatively different, it is qualitatively different. It is a world unto itself, with a thermal and geological life far more complex than its smaller cousins. Imagine its vast frozen surface. Over its eons-long journey through the interstellar void, it has been subjected to a slow but persistent rain of cosmic rays, a form of high-energy radiation that can alter the chemistry of its outermost layers, creating a thin, dark, and perhaps surprisingly durable crust. Now, as the sun's warmth touches it for the first time, this crust acts as an insulator. The heat does not penetrate evenly. Instead, it finds the weak points, fissures, craters, areas where the crust is thinner. Pressure builds up beneath these points until the surface gives way in a spectacular eruption. This is the very nature of cometary activity, But on a body the size of 3I, Atlas, the scale of these processes is magnified to an epic degree. The smooth, non-gravitational acceleration, that ghostly push that so perplexes us, finds its natural explanation here. A larger body has a much greater thermal inertia. It heats up more slowly and more evenly. Instead of chaotic jets erupting sporadically as the body tumbles, a vast active region, perhaps an entire hemisphere that is slowly turning to face the sun, could begin to outgas in a broad, stable, and remarkably uniform manner. The result would be a low-thrust, high-efficiency engine, a continuous, gentle pressure that mimics the behavior of a purpose-built propulsion system, but is, in fact, an emergent property of its grand scale. The intense green glow of its coma also falls into place within this framework. A larger nucleus is a far richer reservoir of primordial material. It could simply be that the region of the alien protoplanetary disk, where 3I, Atlas, formed, was exceptionally rich in the complex carbon chain polymers that, when broken down by sunlight, to produce the diatomic carbon responsible for the green fluorescence. It is not a new or exotic chemistry we are witnessing, but rather a familiar chemistry in an unfamiliar concentration. It is not a different song, but the same song played by a much larger orchestra. And so, we arrive at the great performance, the perihelion passage. In this scenario, the trial by fire becomes a coronation. As 3I Atlas endures the sun's greatest fury, its vast reservoir of volatile ices will be fully awakened. The eruptions on its surface will intensify, liberating an immense volume of dust and gas into the coma. This is the moment the condor unfurls its wings to their full extent. The coma could swell to become larger than the sun itself, a temporary, ghostly atmosphere dominating the inner solar system. The dust liberated by these eruptions, pushed away by the gentle pressure of sunlight, would form a dust tail of breathtaking proportions, a great, curved scythe of reflected sunlight that could stretch across a significant portion of our night sky. The ion tail, a streamer of glowing gas pushed directly away from the sun by the solar wind, would be its brilliant blue spear. For a few precious weeks, it would become a beacon in our heavens, a celestial spectacle of the kind that has not been witnessed for centuries. It would join the ranks of the great comets of history, a silent, majestic visitor that would inspire awe and wonder in all who gaze upon it. Its survival, though not guaranteed, would be a testament to its sheer mass and the potential integrity of its structure. And as it begins its long, slow journey back out into the darkness, it would leave behind a legacy not of profound, paradigm-shifting mystery, but of profound, paradigm-affirming wonder. It would have taught us that the processes that formed our own solar system are not unique. It would show us that other stars also have their own Oort clouds, teeming with icy relics of their formation. And it would demonstrate that nature, working with the same set of physical laws but a different set of initial conditions, is capable of producing objects of a scale and magnificence that can still leave us speechless. This first scenario is the anchor of our inquiry. It is the voice of reason, the pillar of established science. It does not strip 3I, Atlas, of its magic. It simply places that magic within the realm of the natural. It asks us to believe, not in alien engineers, but in the far more patient and powerful engineering of the cosmos itself. It is the beautiful, elegant, and entirely plausible story of the great comet 3I, Atlas. And unless the evidence from its fiery trial forces our hand, this remains the most likely truth. And yet, science must always be a discipline of contingency, a practice of holding multiple competing truths in a state of delicate intellectual suspension until the evidence renders its final verdict. The narrative of the great comet, while elegant and compelling, rests upon a crucial assumption that 3I, Atlas, possesses the internal strength, the fundamental structural integrity, to withstand the immense forces that are about to be brought to bear upon it. But what if this assumption is false? What if, beneath its ancient irradiated crust, this wanderer is not a solid, monolithic body, but something far more fragile? This leads us to the second step on our ladder of hypotheses, a scenario of profound violence, yet one that holds the promise of an even greater revelation. This is the scenario of creative destruction. Let us once again return to our analogy of the celestial manuscript. In our first scenario, the furnace of the sun merely opens the book, allowing us to read its pages as they are illuminated. In this second scenario, the furnace is so hot, the handling so rough, that the book itself, the binding, the spine, the very paper, is torn asunder, its pages scattered to the wind. To a librarian, this would be a catastrophe. To a scientist, however, it could be the ultimate breakthrough. For in this act of destruction, we would be granted a glimpse into something we would otherwise never see. The core, the unadulterated heart of the object, the primordial material that has been shielded from the cosmos since the moment of its birth. This is the story of fragmentation, a narrative that begins with the quiet, insidious work of the tidal forces. As 3I, Atlas is stretched upon the gravitational rack of the sun, every internal flaw, every microscopic fracture formed during its accretion billions of years ago, is put to the test. These are not the grand, dramatic forces of a direct collision, but a slow, persistent, and deeply penetrating stress. It is like the slow bending of a piece of old, brittle wood. For a time it resists, it groans, its internal fibers straining against the pressure. But there is a breaking point, a moment when a single, tiny fracture begins to propagate, racing through the body of the object like a bolt of lightning through a frozen tree. The spectacle would be unlike any other. We would not see a sudden, fiery explosion, but a slow, majestic, and silent unraveling. Great chasms, canyons of shadow and newly exposed ice, might appear on its surface. The smooth, constant outgassing would give way to a chaotic and violent series of eruptions, as these new fissures expose vast reserves of volatile material to the sun's heat for the first time. The object would, in essence, tear itself apart from the inside out. The result would not be a cloud of dust, but a procession, a funeral cortege of newly independent worlds. The original nucleus would give birth to a family of smaller, mini-comets, each one a fragment of the parent body, bound together by their shared origin, and following a nearly identical path through space. This is not mere speculation. We have witnessed this very process before, in our own celestial backyard. In 1994, humanity watched, transfixed, as Comet Shoemaker-Levy 9, which had been torn apart by a close encounter with Jupiter 2 years prior, performed its final act. Its fragments, a string of pearls stretched across the heavens, plunged one by one into the giant planet's thick atmosphere, creating Earth-sized fireballs that scarred its clouds for months. That event was a profound lesson. It taught us that comets are often not solid bodies, but fragile, rubble piles, loose agglomerations of ice and rock, held together by little more than their own weak gravity. Now, imagine witnessing such an event, not with a native comet, whose composition we largely understand, but with an interstellar one. The scientific prize would be almost incalculable. Each fragment becomes a new, independent experiment. The freshly cleaved surfaces of these smaller nuclei would be the most pristine material ever observed by humanity. For billions of years, the original surface of 3I, Atlas, has been slowly weathered by the interstellar environment, its chemistry altered by cosmic rays and ultraviolet light, forming a kind of cosmic patina. The act of fragmentation would be like cracking open a geode, bypassing the rough, uninteresting exterior to reveal the perfect, untouched crystals within. Our spectrographs, pointed at these new surfaces, would be reading a text that has not been seen by any light since the dawn of its home star. We could measure, with stunning accuracy, the true, unaltered ratio of its ices, the precise nature of its organic molecules, the exact isotopic fingerprint of its rocky components. We would not be inferring the nature of its core. We would be observing it directly. The single, enigmatic puzzle of 3I, Atlas, would be transformed into a dozen smaller, more manageable ones. We could study how fragments of different sizes behave, how their rotation and outgassing evolve, providing unprecedented data to refine our models of cometary physics. We could compare the composition of a fragment from the original core with one from the original mantle, creating a three-dimensional chemical map of an object from another solar system. This scenario, then, is a beautiful paradox. It is a story of death and birth, of loss and discovery. The destruction of the single, magnificent object of 3I, Atlas, would be, in a very real sense, a creative act. It would be a sacrifice made upon the altar of the sun, an offering that would, in its violent dissolution, bequeath to us a level of understanding we could never have achieved otherwise. It is a reminder that in the cosmos, as in life, sometimes the most profound revelations are born from the moments of greatest upheaval. It is the story of what happens when the manuscript is not just read, but is torn into its constituent letters, allowing us, for the first time, to see the very ink with which the story of another world was written. And so we arrive at the final, highest, and most treacherous step on our ladder of hypotheses. It is a step that we must take with the utmost intellectual caution, for it leads us away from the firm, familiar ground of established physics and into the ethereal, fog-shrouded landscape of profound speculation. This is the hypothesis of last resort, the explanation we dare to contemplate only when all others, however grand or dramatic, have been found wanting. It is the quiet, insistent question that the data, in its strangeness, forces us to ask. What if 3I, Atlas, is not a natural object at all? What if the anomalies we observe are not the emergent properties of a large natural body, but are instead the designed characteristics of an artificial one? What if we are witnessing not the visit of a comet, but the passage of a relic? This is not a leap into fiction. It is a disciplined, albeit radical, line of inquiry. It begins by taking the very same pieces of evidence that we have already examined and looking at them through a different lens. A lens ground not by the assumptions of celestial mechanics, but by the logic of purpose and design. Let us return to that most stubborn of mysteries, the smooth, non-gravitational acceleration. The conventional explanation, that of stable, large-scale outgassing, is plausible, but it remains an imperfect fit, an explanation that feels stretched, like a garment tailored for a smaller creature. Through this new lens, we are forced to ask a different question. What if the smoothness and efficiency of this push are not accidental but intentional? Could we be seeing not the chaotic sputtering of sublimating ice, but the faint residual signature of a purpose-built propulsion system? We are not imagining a roaring chemical rocket, but something far more subtle, far more advanced. Perhaps it is a vast, ultra-thin solar sail, miles wide but mere molecules thick, catching the pressure of the solar wind and sunlight in a way that our instruments can barely detect, its reflective properties masked by eons of accumulated interstellar dust. Or perhaps it is the dying breath of a magnetic sail, interacting with the charged plasma of the solar wind. Or, in the most extreme of possibilities, could it be the faint, almost imperceptible thermal leakage from a long-dormant internal power source, a nuclear or fusion reactor that, even in its near-death state, still generates enough waste heat to create a gentle, constant thermal thrust? In this view, the push is not a sign of the object's dissolution, but a testament to its engineered nature, a ghost of its original purpose. Now, let us consider the trial by fire, the perihelion passage, the two natural scenarios, that of the great comet and that of the creative destruction, are both outcomes of fragility. One survives through sheer mass, the other succumbs to its inherent weakness. An artificial object, however, would play by an entirely different set of rules. It would have been constructed, presumably, for the express purpose of long-duration interstellar travel. Its hull would not be a random agglomeration of ice and rock, but a material or a composite engineered to withstand the hazards of the void, micrometeoroid impacts, cosmic radiation, and extreme temperature gradients. How would such a structure respond to the sun's interrogation? It might display a resilience that is simply impossible for a natural body. As the tidal forces stretch it, it might not fracture or crumble, but instead absorb the stress with a structural integrity that speaks of advanced material science. As the heat bakes it, it might not sublimate chaotically, but ablate cleanly, its outer layers peeling away like the heat shield of a returning space capsule, a process designed to protect a core that is far more valuable. And this leads to the most spectacular, though least likely, of possibilities within this hypothesis. What if the sun's fire successfully scours away the millennia of accumulated dust and grime? What if the coma, that great shroud of gas and dust, thins for a moment, and our telescopes are granted a fleeting glimpse of the true surface beneath? What would we see? In the natural scenarios, we would expect to see the chaotic, pockmarked, and irregular terrain of a cometary nucleus. But if this is an artifact, we might see something else entirely. We might see the cold, hard gleam of worked metal. We might see the stark, uncompromising lines of geometry angles, curves, and patterns that nature, in its fractal beauty, rarely produces. We might see a surface that is not a testament to random accretion, but to intelligent design. And then there is the silence. The great, profound silence that has met every effort of our radio telescopes to listen for a signal. In a conventional view, this silence is a strong piece of evidence against artificiality. An active, functioning probe or vessel would surely be communicating. But through the lens of this hypothesis, the silence itself becomes a different kind of clue. Is it the silence of a tomb, the quiet of a derelict vessel that has been dead for millions of years? Its crew long since vanished, its automated systems finally failed, left to drift on the currents of gravity for eternity? Or is it the silence of a library, whose books are written in a language we cannot even perceive? Perhaps its communication systems operate on principles we have not yet discovered, using neutrinos or modulated gravitational waves, broadcasting its secrets in a medium we are currently deaf and blind to. Or perhaps, most chillingly, the silence is intentional. Perhaps it is a form of stealth, the quiet passage of a probe designed not to be seen, a watcher that has no interest in announcing its presence. This final hypothesis is the one that demands the most from us, both intellectually and emotionally. It is the one that sits on the knife edge of science and what some would call faith. To be clear, there is no definitive evidence to support it. It is a ghost, an outline, a possibility born from the gaps and inconsistencies in the simpler explanations. But science is not just about confirming what we already know. It is about having the courage to confront what we do not. It is about building a ladder of inquiry and being brave enough to climb to the very top, even if the air up there is thin and the view is unsettling. This scenario represents the ultimate responsibility of the observer, to remain open, even to the most paradigm-shattering of possibilities, until the evidence itself closes the door. The fiery trial at perihelion will be the ultimate arbiter. It will provide the evidence that will either strengthen the foundations of our conventional understanding or force us to reckon with a truth more profound than any we have ever dared to imagine. It is the story of what happens when the manuscript, upon being opened, is found to contain not a familiar story, but a blueprint for a machine we cannot comprehend. And so, we arrive at this moment of profound intellectual vertigo. We have climbed the ladder of hypotheses rung by rung, from the solid, reassuring ground of the known to the thin, rarefied air of the truly extraordinary. We have entertained the narrative of the great natural comet, a story of magnificent, understandable grandeur. We have contemplated the drama of creative destruction, a tale of violent but revelatory sacrifice. And finally, we have stood at the precipice, staring into the abyss of a possibility so vast and paradigm-shattering that it threatens to reframe everything we believe about our place in the universe. The possibility of an artifact, a silent, drifting testament to a mind other than our own. To stand here is to feel the ground shift beneath our feet. It is to feel the comforting, self-assured narrative of human centrality begin to fray at the edges. And in this moment of profound uncertainty, as we await the final, irrefutable testimony from the perihelion passage, it is natural to become fixated on the verdict. We find ourselves holding our collective breath, waiting for the universe to hand down its judgment. Is it nature, or is it artifice? We have framed the entire encounter as a search for this one singular answer, as if the sole purpose of this cosmic visitor is to resolve this binary question for us. But perhaps, in our frantic search for a definitive label, we are asking the wrong question. Perhaps the most important meaning to be found in the arrival of 3I Atlas has very little to do with what the object itself actually is. Perhaps its true significance lies not in the answer it will provide, but in the reflection we see of ourselves while we wait for it. For what has this single, distant point of light, this silent traveler, actually accomplished in its short time within our awareness? It has performed a miracle that no treaty, no ideology, no human leader has ever fully achieved. It has, for a fleeting moment, united our species. Consider the quiet, unheralded symphony of collaboration that is unfolding across our planet. In an observatory high in the arid deserts of Chile, a team of astronomers adjusts the mirrors of a colossal telescope, their language a mix of Spanish and English, their goal identical to that of a colleague in a control room in Hawaii, speaking Japanese. Data, streamed across continents in an instant, is analyzed by a postgraduate student in Germany, who shares her findings on a network with a tenured professor in India. The great radio dishes in Australia and California, instruments built in different eras for different national purposes, now listen in unison to the same patch of silent sky. For the first time, a celestial object has become the subject of a truly global, coordinated, and simultaneous investigation. The eyes and ears of humanity, our most advanced sensory extensions, have been temporarily federated into a single, planetary-scale organism, driven by a single shared impulse to understand. This network of minds and machines, transcending borders, politics, and cultures, is perhaps the most sophisticated and beautiful structure our civilization has yet produced. And it was not brought into being by a threat of war or a promise of profit, but by the simple, irresistible allure of a mystery. 3I Atlas, in its profound indifference, has become a cosmic catalyst for human unity. It has given us a common cause, a shared point of focus in the heavens that reminds us of our shared identity as inhabitants of a single fragile world. In this sense, the object itself becomes a form of celestial Rorschach test, a vast, ambiguous inkblot onto which we project our own deepest hopes, fears, and aspirations. Its true nature is almost secondary to the meaning we choose to imbue it with. When we look at it and argue for the narrative of the great comet, we see a reflection of our desire for an orderly, understandable cosmos, a universe that operates on principles we can grasp, a place where even the most majestic events are ultimately natural and, therefore, not threatening. It reinforces a worldview of quiet confidence in our scientific models. When we contemplate the scenario of its destruction, we perhaps see a reflection of our own anxieties about fragility and impermanence, a memento mori on a cosmic scale, a reminder that even the most ancient and enduring things can be unmade in an instant. And when we dare to whisper the hypothesis of an artifact, what are we truly seeing? We are seeing a reflection of our profound, aching loneliness in the universe. We are projecting our deepest, most ancient yearning for connection, our hope that the silence of the cosmos is not an answer, but merely a pause between speakers. We see our own drive to build, to explore, to leave a mark mirrored in a hypothetical other. At the same time, we project our fears, the fear of the unknown, the fear of an intelligence so advanced that we are to it as insects in the grass. 3. Atlas holds up a mirror to the human psyche, and in its faint, enigmatic light, we are forced to confront the dualities that define us, our courage and our fear, our arrogance and our humility, our desire for simple answers and our capacity to embrace profound mystery. This, then, is the meaning of the encounter. It is not a passive event happening to us. It is an active process happening within us. The journey of this object through our solar system is paralleled by a journey through our own landscape of ideas. It is a powerful testament to the fundamental nature of a conscious mind. The universe, as far as we know, operates on the silent, unthinking principles of physics. 3. Atlas is not aware of its own majesty. It feels no awe as it approaches the magnificent, terrifying furnace of the Sunday. It has no sense of its own ancient history or its singular destiny. It is a thing of sublime beauty and complexity, but it is a beauty without an observer, a complexity without a mind to comprehend it. Until us, we are the universe's organ of self-awareness. It is our consciousness that transforms a set of orbital parameters and spectroscopic data into a story, into a drama of discovery, into a source of philosophical contemplation. The act of observing 3I, Atlas, of striving to understand it, is an act of creation. We are the ones who weave the tapestry of meaning around the cold, hard threads of fact. The encounter's true legacy, therefore, is not a new line in a textbook, but a new question etched into our collective soul. It is a powerful reminder that the exploration of the cosmos is, and has always been, an exploration of ourselves. The quest is not just to find out what is out there, but to understand what the search itself reveals about who we are, right here. Soon, perhaps in a matter of days or even hours, the climax will be reached. The perihelion will pass. 3I, Atlas, in whatever state it finds itself as a triumphant, glowing supercomet, as a ghostly procession of fragments, or as a stubbornly resilient and enigmatic artifact, will begin its long, inexorable journey away from the sun, its velocity boosted by the gravitational slingshot, its trajectory now aimed squarely at the empty darkness of the interstellar void. It will recede, the spectacle will fade, the frantic, around-the-clock observations will taper off. The object that has been, for a brief time, the brightest and most compelling mystery in our sky will shrink back into a faint, insignificant point of light, accessible only to our most powerful telescopes, before finally, inevitably, vanishing from our sight and from our lives forever. It will not return in our lifetime, or in the lifetime of our civilization, or perhaps even in the lifetime of our species. Its passage is an ephemeral brushstroke on the canvas of our history. And once it is gone, what will remain? What is the lasting inheritance of this fleeting encounter? The most tangible legacy, of course, will be the data, petabytes of it, a vast digital ocean of numbers representing spectral lines, orbital deviations, light curve fluctuations, and polarization measurements. This data will be the raw material for a generation of scientific inquiry. It will be the foundation for thousands of scientific papers, the subject of countless PhD theses, the catalyst for decades of debate and analysis at astronomical conferences. Models will be built, simulations will be run, and our understanding of cometary physics, of the interstellar medium, and of the chemical diversity of the galaxy will be refined to a degree that was previously impossible. This is the concrete intellectual inheritance of 3I, Atlas, It is a gift of pure knowledge, a set of new pages for the great, ever-expanding encyclopedia of the cosmos. It is a legacy of questions answered, and more importantly, of newer, more sophisticated questions that we can now begin to ask. But beyond the data, there is a deeper, more philosophical legacy that will be left behind, one that is not stored on hard drives, but is imprinted upon our collective consciousness. 3i, Atlas, will leave us with a profound and renewed sense of wonder. In an age where so much of our world can feel mapped, measured, and demystified, this visitor has served as a powerful antidote to certainty. It is a visceral reminder that we live on a small, sunlit island in the midst of an ocean of mystery that is deeper and vaster than we can possibly imagine. It has reminded us that the universe is not a solved puzzle, but an unfolding story, and that it still possesses the capacity to surprise us, to challenge our assumptions, and to leave us in a state of genuine, unadulterated awe. For those who witnessed its passage, whether through a backyard telescope or a live-streamed observatory feed, the night sky will never look quite the same again. It will no longer be a static backdrop of familiar constellations, but a dynamic and permeable membrane, a thoroughfare through which other stories from other worlds can and do pass. And finally, the most important legacy of all is the question that will hang in the air long after the object itself is gone. The encounter with 3i, Atlas, has forced a conversation that our civilization has, for the most part, relegated to the fringes of science and the realms of fiction. It has taken the Fermi paradox, the great, unsettling silence in a universe that should be teeming with life, and moved it from a thought experiment into a tangible, observable event. We have now, as a species, looked upon an object and been forced, by the integrity of the scientific process itself, to seriously consider the possibility, however remote, that it might be an artifact of another intelligence. That conversation, once started, cannot be easily unstarted. The door, once cracked open, cannot be fully closed. 3i, Atlas will leave us with the echo of its passage, a lingering what-if that will subtly reshape our perspective. It normalizes the search for techno-signatures, making it not a fringe pursuit, but a necessary and logical component of our exploration of the cosmos. It becomes a permanent part of our story, a celestial ghost that will haunt our future endeavors, forever urging us to look closer, to listen more carefully, and to remain open to the possibility that the next faint point of light to wander into our view might be the one that ends our cosmic solitude. The visitor will depart, but the visit and the profound questions it has raised about the universe and our place within it will stay with us. That is its enduring gift. And so, we find ourselves here, at the quiet end of the drama. The great play is over. The celestial actors have taken their final bow, and the curtain of distance is now drawing closed. The legacy of the event, both in data and in spirit, will be woven into the fabric of our future. But the truest and most personal inheritance of this encounter is not found in a laboratory or a lecture hall. It is found in the stillness of a clear night, in the simple, ancient, and profoundly human act of looking up. Find such a night. Stand outside, away from the glare of the city lights, and let your eyes adjust to the darkness. Feel the cool air on your skin. Listen to the silence of the earth around you. And then, look up into that vast, velvet expanse, scattered with the cold, diamond dust of 1 trillion suns. The sky is the same sky that your ancestors looked upon. It is the same sky that Galileo charted, the same sky that inspired the poets and terrified the priests. And yet, for you, it is now different, because you know that it is not a fixed and distant ceiling, but a place of passage. You know that behind one of those faint points of light, a story is unfolding, a civilization may be rising or falling, and you know that from the unimaginable darkness between those lights, a visitor has come and gone. It crossed our path, a fleeting shadow, and in its wake, It changed the very character of the darkness. The emptiness is no longer empty. It is pregnant with possibility. The silence is no longer the silence of absence, but the silence of a listener, waiting. The great journey of 3I, Atlas through our solar system, is now ending. But the far more important journey, the one it has ignited within us, has only just begun. The quest to understand the universe is, in the end, a quest to understand the consciousness that is able to ask the question. The visitor is gone, but the sky and the wonder and the great, beautiful, terrifying questions remain, and they are, now, a part of us.